We have Dom Delano from Pixie talking to us about monitoring Cassandra without instrumentation using eBPF, as mentioned. eBPF is a powerful Linux kernel technology that's used for observability, networking, and security. And in this session, he's going to do a live demo showing eBPF, monitoring of Cassandra using only open source projects. It can help you quickly identify services and pods that send and receive Cassandra requests, inspect individual requests and responses, and calculate request latency, error rate, and throughput. Dom, I will turn it over to you, and we are excited to see your presentation.
As Melissa said, my name's Dom. I'm an engineer at New Relic working on the Pixie open source project. And today we're going to talk through how the Pixie project can help you monitor Cassandra without instrumentation. So we've already kind of introduced me, but I mentioned I'm a full-time contributor to the Pixie project while I'm a New Relic employee. Prior to working at New Relic, I was at Twitter working in the observability space, and I saw a lot of value in Pixie and got involved as an external contributor. So while I've only been a New Relic employee for the last 4 months, I've been working on the project for a year and a half. So what is Pixie? It's a eBPF observability tool for Kubernetes. And our goal is to provide auto instrumentation for your applications. So you put Pixie on your cluster and you don't need to make any code changes, but we're able to provide this deep introspection so you can debug the applications on your cluster and figure out where the errors are happening and root cause things. And we do that through the eBPF Linux kernel technology, which we'll talk about more in just a little bit. We also have this edge compute property where Pixie, because eBPF allows us to collect a large volume of data and keep that very high granularity, we run Pixie on the edge, meaning on every single node in your cluster, and all of the data that gets collected stays locally. And when you go to access it or debug things, we actually federate the queries across the cluster, filter things locally where possible before returning the data. And all of the UI components of Pixie that we're going to see later today are completely scriptable. So you're able to change like the UI widgets, change how the data is filtered or aggregated. It's all done through a Python interface, and we'll see more about that in just a bit. So to briefly go over what we'll be talking about today, we're going to do an introduction to eBPF and make sure we kind of have some ground for what it is and what it unlocks. We'll dive a little bit deeper into what Pixie provides. From there, we will look into Pixie's protocol tracing, which is one of our biggest features. And for the Cassandra audience here, this is what allows us to see all of the traces that are happening in your cluster. So you'll be able to see all of the Cassandra requests and responses. Cassandra is just one of many protocols we support, but there's a lot of rich context that we can get from seeing all the traffic in your cluster. We'll then jump into a demo and see it in action. And then I wanted to spend some time talking about my vision for the future of Pixie's Cassandra integration. So what is eBPF? I think it's helpful to use an analogy to describe it. If you're familiar with using a debugger, you can think of, so there's the eBPF program, which is the code that you write, and then there is the probe or like the attachment of the program. And so that probing, you can think of like a debugger breakpoint. And so eBPF is event driven. So in this example on the right-hand side, imagine that we have a event fired when the sendPong function gets called. In eBPF, what would happen is when your application calls sendPong, the kernel would then switch over to your eBPF program, run the instrumentation. In this case, it just increments a counter to know how many times our probe triggered. And then the kernel will switch back to your application and continue execution. For this example, we're looking at eBPF probing a like user space process, but there's actually a variety of events that eBPF can integrate with. So syscalls and kernel functions are another popular source, and that's actually what we'll dig into when we look into the protocol tracing. In addition to, there's other use cases such as like running BPF programs in network drivers. So there's a lot of flexibility and power with this technology. So why does Pixie use eBPF? eBPF allows us to get access to data at the kernel level, and the kernel has this global view of the system. There's certain things that you can only access if you have this global view, and that provides a really great opportunity for instrumentation. And for what's relevant to all of you working in the Cassandra space is that because it works at the kernel level, we're able to instrument applications automatically and agnostic to programming language in many cases. So you as the application developer don't need to duplicate instrumenting things in the variety of programming languages that you use, or depending on, what client libraries and other things going on. eBPF can get this large breadth of coverage because of the area that it works in. Another benefit of eBPF is if you are working at the kernel level, kernel development's typically very slow and dangerous at times. There's not a lot of safeties you get. eBPF allows you to rapidly iterate, and the engine that verifies BPF programs actually guarantees that your code is safe. You're not able to load a program that loops endlessly or can crash the system. So you're able to work at the kernel level with rapid pace, but having the comfort knowing that there's a lot of safety guarantees built in. And the final point is these eBPF programs are JIT compiled to native code. And so they're extremely efficient when they run. And we're able to capture all of these events in real time. So we don't do any sampling. We just have access to the fire hose of data, which is why Pixie has this architecture where data is kept on the node it was collected rather than centrally storing it. Now that we have that BPF background taken care of, let's dive a little bit deeper into Pixie. So as I mentioned before, a goal of Pixie is to debug your applications without manual instrumentation. Some of the data that you're able to see with Pixie includes the typical resource utilization, CPU, memory, and network usage. Protocol tracing is also a really powerful capability where you can see all of these spans, which are the requests and responses happening between all of your microservices or to your data stores like Cassandra. And we'll see concrete examples of that later. We also do always on flame graph profiling. So for those that aren't familiar with flame graphs, this is a way to debug why an application is using a lot of CPU and get to the root of where the hotspots are in your code. And that's something that Pixie provides out of the box as well. Let's dig into protocol tracing a little bit more. Here's an example of Pixie's view of all of the HTTP traffic within a cluster. We can see that each row includes the details of a request and response pair, and we are able to determine which source and destination pod the traffic originated from. We can see the request path, the latency of the requests, and all of the data in the response body. HTTP is just one of many of the protocols Pixie supports. We do DNS, we do Cassandra's wire protocol, which is CQL, and in addition to many more. These slides will be shared in the agenda doc for today, so you can go check that link to see everything that we support later on. Before we get into the Cassandra specific tracing, I wanted to talk a little bit about how the eBPF programs for this work under the hood. So we talked about how eBPF programs are like a breakpoint debugger. And for the Pixie protocol tracing, what our event is when read or receive from or send to syscalls happen, which transmit the network data. So imagine that you were curling google.com on your machine. These send to and receive from syscalls are what would be triggered as a result of that. And Pixie's eBPF program is running when these syscalls occur. So you can see that the second argument to these contains the payload of the request and response. And so how Pixie processes this is the BPF probes capture those raw payloads. We then access them in the Pixie Edge module, which is the component that runs on each node, and process them in user space. And that user space processing allows us to enrich the data with Kubernetes details, as well as matching up the request and response pairs so that we can tell you which, the actual traces that occurred. What about TLS traffic? In today's environments, there's a big push to make sure things are extremely secure out of the box. And so using TLS or MTLS everywhere is becoming more common. Fortunately, eBPF and Pixie can handle that as well. Today, we currently support OpenSSL and GoTLS. So if you're using those libraries, we're still able to give you that full end-to-end visibility. We have support coming for Netty TLS tracing. For those that aren't familiar with Netty, it's a Java networking library that's pretty popular. And Cassandra actually uses Netty. So once Cassandra upgrades to a Netty version later than 4.1.78, it will unlock the capability for us to do TLS tracing for between clients and servers of Cassandra and also with the internode traffic as well. For those that are interested in the details there, I gave a talk on this at eBPF Day last year, so I encourage you to check that out. All right, with that, let's see how Pixie works in action.
I've went ahead and deployed a demo application that uses Cassandra to my Kubernetes cluster. In addition to that, I've also deployed Stargate, which is a data proxy that can sit in front of Cassandra that allows you to access your data over GraphQL or a REST API. This will be useful for us to generate traffic of different types, Cassandra, HTTP, so that we can investigate what traffic is flowing on this cluster. If we look through the UI, there's just a couple of pages, but they essentially query a few tables that exist within this Cassandra cluster. This demo will be available through the Pixie CLI, so you'll be able to give this a try yourself in a week or so. Switching over to the Pixie UI, here's the default view that you get, which shows you a service map of all the HTTP traffic across your cluster. In addition, we can see that there's some information about the nodes in our cluster and the resource utilization, how many pods they contain, and some details about the Kubernetes namespaces that exist in the cluster. We can also see some information about the Kubernetes services, and it gives you some rough distribution of the latency and throughput error rates that we're seeing across the cluster. So these visualizations are powered by a language called Pixel, which is a Pythonic language that allows you to customize these views. So while we provide a variety of scripts out of the box, such as Cassandra related scripts or HTTP, you also are capable of changing the source for these and customizing them as you see fit. Let's dig into the Cassandra traffic that's flowing on the cluster. So you can see here that we are looking at the CQL data Pixel script. And prior to loading this, I caused one of the nodes in the cluster to go down. So we can see that there is a response opcode event that was generated as part of this. And looking at the response body, we can see exactly which node went down. From there, the pet clinic application that we were just looking at seeds many of the tables that the application uses. And so after the node came back up, we can see that there are a variety of requests and responses that are triggered. So we can see the application authenticating with the Cassandra cluster. We can see that there's a variety of querying happening. In addition to that, it's creating some tables and indices in addition to seeding some data. Switching over to the HTTP data script, we can see all of the HTTP traffic that is flowing throughout the cluster. In this case, we're looking specifically at the Stargate deployment, which sits in front of Cassandra, in addition to the Pet Clinic backend, which is the API for the Pet Clinic website that we were just looking at. Pixie is able to see the full request and response bodies, so we can see the request path. We can see that there's a variety of endpoints being hit. We can see all of the headers that are being provided, in addition to the response codes. So we can see that there are some requests that are returning with 200 status, and then we have a variety of requests that are getting 400 level errors. Inspecting this one with a 400 response status, we can see that it is missing a required parameter, which is resulting in that error, in addition to requests that aren't providing credentials, so they're getting a unauthorized error.
All right, so there's Pixie at a view of all of the traffic that it can see. Being able to automatically capture all of the requests and responses really aids in debugging performance problems or application issues. So there's a lot of flexibility and power there. All right, moving on to the future. So some of the short-term things is that we need to expand Pixie's support for Cassandra's CQL wire protocol. We parse all of the message frame types, but there's room for improvement for all of the metadata and the full response bodies. Today, we currently support V3 and V4 of the protocol. V5 is now stable and I believe in use. So we are going to be addressing that in the near future. This is an opportunity where if you are interested and excited about Pixie, that it's a great way to get involved with the project and help us push forward for making sure that Cassandra is battle tested and supports all of the things that the community would widely use. I also mentioned that NetE TLS tracing support is coming. I think there's a lot of potential here. If Pixie were to support the gossip protocol and the other internode traffic, Pixie would be able to get a full end-to-end view from the client, which may or may not be using Cassandra, all the way down through the data store and the traffic between the nodes. So I think there's a really great opportunity to understand your architecture at a deep level if we're able to support all of the traffic through that path. Thinking a little longer term, I want to investigate how to do always-on key visualization. So the Bigtable and TIDB projects, they actually have a key visualizer. So for these data stores, one thing that you need to be mindful of is if your data model and your data usage actually is evenly distributed. And so, for instance, like if you have even distribution, like in this top left-hand corner, it means that your data is modeled correctly and you're not hammering particular instances. Looking at a more problematic case, this hot key range, in the Cassandra world, this would be similar to if you had some of your data ending up on the same node and your query patterns start causing performance problems because you're always loading data from one instance, and at some point that will fail to scale. So CQL, the wire protocol of Cassandra, actually includes some partition information in some of the frames. And so I think there's a potential here for Pixie to actually generate these on the fly. And so if you were debugging a production issue and you wanted to understand if there was issues with the data access pattern, you would be able to understand if there are hotkeys at play or not very quickly, which I think would be incredibly powerful. And just one final plug, we really enjoy working with the community. So if you're excited about this stuff, we would love to work with you. I can speak from firsthand experience as someone who was working externally to the project. The Netty TLS tracing was actually something that I worked on while at Twitter with the Pixie team. And there was a lot of great collaboration there. And so we're excited getting people involved and working within the community. With that, I want to thank you for your time. I'm also happy to answer any questions in the Zoom chat after this. And I provided some links to our website and our GitHub. And this link to this presentation is already in the agenda doc for this meeting. So any of the links or content that you want to look at, you can access it from there. Thanks, everyone.
It's awesome to see projects like this that want to connect with Cassandra. And it looks, you shared some links about if people are interested in Pixie, where can they start? Go to the Pixie website. And where can people find you if they have questions about how to get started and collaborate with Pixie?
We have a community Slack, so that would probably be the best place to join, and we can talk about all these exciting Cassandra things that we talked about.
Fantastic. Well, thanks so much, Tom. We really appreciate your time.
Thanks for having me.
If you want to get involved in the project, there are many different ways to participate. You heard about some of them here. Of course, join the Cassandra Slack on ASF, look at the Cassandra Apache website, and find out how you can start to contribute. The CEPs are a great way to get involved. The contributor meetings are where we talk about those different CFPs, and we'll talk about how you can contribute there. You can also submit a talk for this town hall, as well as other events that we're doing. There is a form in the town hall agenda that's you can submit, kind of tell us what you want to talk about, what are the topics you can share your expertise about, let us know. And if you want to organize a local meetup, there's a handbook link in the agenda as well. And you can also join the Planet Cassandra Discord. We hope that you join us for the next town hall. If you have any questions for any presenters, you can find them on ASF Slack, various other channels, and we will see you again soon. Thanks everybody for joining.